Wow, a lot has happened this morning from the delay to now Blackboard's not working. I literally sat up here at one point and just watched Netflix while I continued to click refresh on Blackboard. And did it work? Nope, sure didn't. But I'm here for you. I still want to see you in class, so hopefully we'll be together next week. I'm recording this for you to fill in your notes. So open them up in another tab or have them printed out in front of you to fill in because I'm going to fill them in with you. I'm even going to do our little experiment with these wonderful blocks that I intended to do in class today. So please follow along and fill in your notes. All right, here we go. All right, so in Google Classroom, you should see, you could actually it's probably quicker if you go to classwork and you have this week 1 planner. This is where your notes are attached. Again, either print them off or open them in another tab. Pause the video if you need to do that at this time. Okay, hopefully you're back and ready to go. So these are the notes that you have. Let's start filling them in. Probability is the measure of how likely an event is to occur. All probabilities go from 0 to 1. 0 meaning impossible, certain meaning 1 meaning 100%. So probabilities are written as fractions or decimals or percentages from 0 to 100%. All right, an event is a specific result in a probability experiment. When rolling a number cube, which is what the state likes to say because a die can be anything, a die is the singular form of dice. Dice means more than one. So they say number cube. That way they can kind of say, oh, it's got these numbers on it. I don't know. It's a fancy thing, whatever. So number cube, the event of rolling an even number can occur in 3 ways. So an event is a specific result in a probability experiment. An outcome is a possible result of a probability experience. For example, when rolling a number cube, the possible outcomes are 1, 2, 3, 4, 5, and 6. Okay, so the event is what we're looking for, and the outcomes are the denominator, what total it is. So what's the probability of getting heads? Well, the event, what we're looking for is a head, and there's 1 out of 2 outcomes. So that gives us 1 out of 2, 0.5, or 50%. So I'm going to flip to my screen to where you can watch me, and I want you to record the results in a minute. Let me backtrack. Back that up a minute, sorry. Okay, theoretical probability. Theoretical probability is what should happen. I have not done the experiment yet, so we're going to calculate what should happen when I do the experiment. What is the probability that we will pick red? Miss Burke, the probability is 3 out of 10 because there's 3 red blocks out of 10 total blocks. Why, thank you, Lucas. I'm glad you participated today. Yeah, we'll just pretend. I'm not going crazy or anything. So the probability of getting red is 3 out of 10 or 0.3 or 30%. I don't have a preferred way for you to write it. Most commonly we use a fraction and put it in simplest form. What is the probability that we will pick blue or yellow? Miss Burke, over here. Yes, Heidi, what do you think my answer is, blue or yellow? Miss Burke, it's 5 out of 10 because there's 4 blues and 1 yellow, so together that makes 5, and 5 out of 10. Miss Burke, over here. Why, yes, Anderson, what do you think the answer is? Well, you could simplify the answer and get it to be 1/2. Oh, why, thank you, Anderson, you are correct. All right, so 1/2. Now, what is the probability that we will pick blue or yellow? 1/2. Well, it's probably that we will pick not red. So let's see, we have 4, 5, 6 that are not red. So that's 6 we want out of 10 that are possible, which simplifies into my human calculator. Help me out, Lorenzo. 3 out of 5. Thanks, Lorenzo. Great job. All right. Okay. Now, I'm going to flip it to the camera, and you need to keep track of the experiment. So right here, you could use X's to keep track of how many times I pull that color. I'm going to have to come back and update it. So let me switch over. Hi again. So here are my blocks, just the same ones that are in your notes. So I have this lovely little box, which I use for my Chinese students. We have lessons on like on, above, in, between. So I use my box to help me with that. So that's why I have a little box up here. All right. Oop, almost dropped it. All right. All my blocks are in here. All right. So you're keeping track. Put an X down. All right. I'm going to have to keep track too so I can update it. Red, green, blue, yellow. All right. Not looking. Red. So put an X by red. Now I'm replacing it. So put an X by red. All right. Blue. Put an X by blue. Red. Put an X by red. All right. Yellow. Put an X by yellow. Green. X by green. Blue. Green. So far I have 2 red, 2 green, 2 blue, and 1 yellow. So that's 2, 4, 6, 7 times. I think I'm going to try to go up to, let's try 20. I don't know. We'll go a little faster. So I will repeat the total and you'll see the total if you lose track. Blue. Red. 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 Check that up. Green. Yellow. Blue. Red. All right, let's see. I've got 5, 6, 7, 8, 9, 10, 11. Wait, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, 5 more pulls. Red. Blue. Blue. Red. Let's see, 5, 10, 15, 16, 17, 18, 19. Okay, last one. Blue. All right. Pause, and I will give you the total in a minute. All right, so I've updated your probabilities. I pulled red 8 times, so I have 8 X's. I pulled yellow twice, green 3 times, and blue 7 times, for a total of 20 times. Now, experimental probability, I actually did the experiment. I didn't just say, oh, well, you know, hey, there's 4 out of 10 that are blue, so my experimental probability does not always match my theoretical. Theoretical's what should happen. Blackboard theoretically should have worked today. You should be in class right now with me. That's all theoretical for today. Experimental, what's actually happening? You're watching a video and filling in your notes, which I'm trying to entertain the best I can here. Okay, so what is the probability that we picked red? So now I need to look at my experimental results. So I picked red 8 out of 20 times, which would simplify into 4 out of 10, which would simplify into 2/5. Yes, I still have to do it that way. Don't judge me. Okay, what is the probability that we picked blue or yellow? So let's see, we had 7 blues plus 2 yellows, so that's 9. So that's 9 out of 20, which I can't simplify. What's the probability that we did not pick red? All right, so let's see. 7 plus 3 is 10, plus 2 more is 12. So 12 out of 20, which is 6 out of 10, which is 3 out of 5. All right, so did our probabilities match? Well, actually, the probability of not picking red matched. That just happened to be a coincidence. Blue or yellow, we said 1/2, and we got 9 out of 20. We were close to getting 1/2. That's not bad. And picking red was supposed to be about 3 out of 10 or a 30% chance. And we ended up getting 2 out of 5, which is about a 40% chance. So we picked red more than we theoretically should have. But that's the thing with the experiment. You can't predict how it's going to go. All right. Donald is rolling a number cube labeled 1 to 6. What is the probability of the following? Rolling an odd number. So let's see. If he's got a number cube, he's got 1, 2, 3, 4, 5, 6. Well, 1, 3, and 5 are odd numbers. So that's 3 out of the 6 faces that are odd. So that simplifies into 1/2. Rolling a number greater than 4. Greater than 4. Is 4 greater than 4? No, it is not. Thank you, class. You're so smart. So 5 and 6 are the only possibilities. So 2 out of 6, which equals 1/3. All right. What is the probability of rolling? What is the probability of rolling a multiple of 2 with one toss of a number cube? All right, class. Let's review factors and multiples. Let's see. A factor. So if I had a number like 10, factors of 10 would be 1 and 10, 2 and 5. Multiples of 10 would be 10, 20, 30, 40, 50, 60. Just a little refresher there. So what's the probability of rolling a multiple of 2 with one toss of the number cube? Pause this video and try to calculate it on your own. Welcome back. So the probability of rolling a multiple of 2 with one toss of the number cube. Multiples of 2 would be 2. Yes, it counts because 2 times 1 is 2. 2, 4, and 6. So that's 3 out of 6, which simplifies into 1/2. All right, number 9. Try to solve this one on your own. What is the probability that a spinner with 5 congruent sections, numbered 1 to 5, will stop on an even number? Pause this video and try to calculate it. Glad you came back. All right, so let's see. Stop on an even number. So we have 2 and 4 are the only even numbers. So that's 2 even numbers out of 3. So my probability is 2/3. All right, so I am going to work on a link for this student.desmos.com that I am going to put in there, and I expect you guys to go finish that on your own for our class time today. I will be watching it during our class time. So if you log on during our class time today, I will be watching it and possibly giving you feedback. All right, thanks for viewing my video. And I seriously hope to see you without technical glitches next week, this week, whenever you're viewing this. I miss you guys. I want to be back in our classroom. My kids are driving me nuts on occasion. My husband too. But anyway, it's beside the point. I probably look like this chicken right here. I don't know. My son made it. I miss you. Is that obvious? All right. Bye, guys.